Hello everyone, welcome to Understanding Physics. It's me Sunitha Mahajan. Today I'm going to explain some foundation concepts for 5th standard students for the topic measurement. In our previous class, I covered about measurement of volume. Today I'm going to explain for you what concepts are measurement of mass and measurement of weight. Okay, first of all, we should know what is meant by mass. The mass of a body is defined as the amount of matter contained in it. We'll be saying it as a mass. So whatever the amount of matter, amount means small quantity. Matter means you know very well. Everything is made up of matter and it will be existing in three states, that is solids, liquids and gaseous state. So this mass is also made up of matter only. So whatever the amount of quantity you are taking, that one will be saying it as a mass. And what is the SI unit of mass is? The SI unit of mass is kg. This also we learned in our previous classes. Suppose if we discuss about this mass word we discuss in fundamental physical quantities. So this is one of the fundamental physical quantity. And when we are discussing about the SI unit of mass, this also we discussed in our previous class. That is in our system of international system, we discuss the SI unit of mass is kilogram. So let me write it on the board. The amount of matter contained in it is called mass. And what is the SI unit of mass is? SI unit of mass is kilogram. Okay, now coming for multiples and submultiples. This also we covered a little bit in our previous class. Now here we are going to discuss some multiples and submultiples of this mass. So first of all, we should know what is meant by multiple. Multiple means whatever the unit which is bigger than the kilogram, will be saying it as a multiple. And submultiples means whatever the unit which is less than the kilogram, will be saying it as a submultiple. So I want to give some multiples and submultiples here, that is 3 to 4, and remaining you will be learning in your 6th standard. At a time if I give all the multiples and submultiples, you will be having a lot of confusion. So just I want to give 3 to 4 here. So let me write it on the board. That is 1 quintal. 1 quintal. It is a multiple of kilogram. So 1 quintal is equal to how many kgs means? 100 kg. Okay, 1 ton. 1 ton is equal to how many quintals means? 10 quintals. If you want to write in kgs means, how can you write means 1000 kg. So 1 quintal is equal to 100 kg. 10 quintals means 100 into 10, how much? 1000 kg. So that's why we can convert from quintals to tons and tons to quintals. These are the, you will be learning in conversions, this one. Okay, now coming for submultiples. In submultiples means less than the kilogram. So 1 kilogram is equal to how many grams? 1 kilogram is equal to 1000 grams. And another submultiple is 1 gram is equal to how many milligrams? 1 gram is equal to 1000 milligrams. So here I explain you the 5 different values. What are the 5 different values is? The first one is 1 quintal. 1 quintal is equal to how many kgs? 100 kgs. And 1 ton is equal to, if you want to write in quintals means, we can write it as 10 quintals. If you want to write in kgs means, you can write it as 1000 kg. Now coming for submultiples. Submultiples means less than the kilogram. So 1 kilogram is equal to how many grams? 1000 grams. And 1 gram is equal to how many milligrams? 1000 milligrams. So what are the concepts we covered? The definition, first one. Next one is unit, that is SI unit of mass is kilogram. Suppose if you want to write in CGS unit, that we discussed already. So let me explain once again. That is CGS unit of mass, if you want to write, we can write it in grams. In FPS system, if you want to write, we can write it as pound. Okay, now next we discussed about multiples and submultiples, these 5 values. Please try to remember and revise that one. By that way, you can remember well. And coming for the instruments, what are the instruments which we are having for measuring the mass? Is different types of instruments or devices we can say we are using. and we'll be seeing that one in our daily life. When you go to provision stores or when you go to grocery shops, groceries for buying the groceries for grocery shop or otherwise supermarket or vegetable market, there you can see all these types of different instruments and devices. What are the different devices and instruments is, let me write it on the board. The first one is beam balance. The second one is common balance. The third one is physical balance. Okay, where we will be using this beam balance, common balance, and physical balance means beam balance will be using especially whenever we are going to jewelry shops. Whenever we will go to jewelry shop, there you can see this beam balance. Why it will be using there only? Why it is not useful in other places means by using this beam balance, we can measure only the smaller quantities accurately. The measurement is accurate, but by using this beam balance, we can measure only smaller quantities. We cannot measure the larger quantities. For that purpose only it will be used, especially used in jewelry shops. Whenever we will go to jewelry shop, we are unable to take larger quantities. There we will be taking smaller quantities only. So there, what happens, we have to take the jewelry in grams or milligrams. So for that purpose, it will be used in jewelry shops. We will buy gold, silver, or platinum. For that purpose, will be used in jewelry shops. Now coming for common balance. We can see this common balance whenever we will go to fruits market or vegetable market or provision stores. There we can see that common balance. And coming for physical balance in supermarkets, we can able to see this physical balance. It will be used by using the battery, electric battery, and it will working like a mission. So that's why we'll be saying that one as a physical balance. So these three types of instruments will be used for measuring the mass. And one important point about the mass is constant everywhere. It is not at all going to change its value wherever you will go. Suppose if you are moving from here to another planet, or if you are moving from here to the satellite of our moon, there also it is not at all going to change the value. But when we discuss about the weight, it is completely different. Weight will be changing from place to place. But mass is constant everywhere. It is not at all going to change its value. So that point you should remember. Okay, now let me discuss about the measurement of weight. What is the difference between this mass and weight? If you understand this one, it's very easy for you. Mass, suppose you have taken your weight of your body. That is 50 kg. When you went to fruit market, there you took some fruits. So the weight, whatever the fruits you took, that is 5 kgs. So whatever the mass of that object will be that only, but the weight will be changing from place to place. Why it will be changing from place to place? The weight, it will be depending upon the force of gravity on an object. Whatever the object you are taking, if you what on that object, whatever the force of gravity will be acting on that object, it will be having that value. The force of gravity will be changing from place to place. Suppose the gravitational attraction will be here different and in other place it will be different. So if it is having more gravitational force of attraction, it will be having more weight. On the surface of the earth, it is 9.8 meter per second square. Suppose if you are going anywhere on the surface of the earth, the value is constant, 9.8 meter per second square. But whenever you will move from this place to another planet or satellite, the force of gravity will be different. So it will be completely new for you, this word gravity. Let me explain about you the word gravity. The gravity is gravitational force of attraction. You know very well, our earth is having gravitational force of attraction. Due to that gravitational force of attraction only, whatever the objects or any particle or any body will be falling on towards the earth. So due to that force of gravity only, this gravitational attraction only, on the earth, what is the gravitational attraction? That is gravity value is 9.8 meter per second square. Okay, now coming for units. The units will be same for this weight and mass. There is no change in the units. Whatever the units you are writing for this mass, the same units you can write it for weight also. But coming for the definition, it is different. The force of gravity, whatever it is acting on the object, will be saying it as a weight. And coming for mass, the amount of matter contained in it will be saying it as a mass. And units, Just now I said the same units. And coming for one point, that is important point we discussed in mass, that is mass is constant everywhere. When we are discussing about weight, weight will be changing from place to place, means weight is not at all constant. And the next important point is on the surface of the earth, what is the gravity value? That is 9.8 meter per second square. We are going to discuss this gravity concept in our next topics, that is kinematics and Newton laws of motion. So our next topic is kinematics and Newton laws of motion. In that one, I'll explain you clearly in detail about this gravity concept. Now just I want to give the value for the gravity, that is 9.8 meter per second square. So whenever you want to write in the form of weight, just you have to multiply that mass value with this 9.8. So when you are multiplying with 9.8, whatever the value you are going to get, that is only your weight. So in that way, we have to calculate. So now coming for instrument, which instrument we'll be using for measuring this weight is, especially we'll be using the spring balance. We'll be using the instrument spring balance for measuring weight. So these are the small concepts which we covered today. That is measurement of mass and measurement of weight. I want to explain one or two problems. So by that way, you'll be understanding clearly about this measurement of mass and weight. Okay, let me rub the board. Revise all the values and concepts, whatever we discussed up to now. So by that way, you can remember each and everything and you can follow the concepts what we are discussing now. Now I want to explain one numerical. Convert 1 gram into kg. Okay, what we know? We know that 1 kg is equal to 1000 grams. Right here, we know that 1 kg is equal to 1000 grams. Now I want to convert this grams to kg. Now, if I want to write 1 gram is equal to how many kgs means, I can write it as 1 by 1000 kg. So in 1000, how many zeros are there? 3 zeros are there. If I want to write in the form of power, how I can write? I should take the base number as 10. So take the base number as 10. After that, how many zeros are there in 1000 count? 1, 2, 3. So I write here 3. Now again in more simpler form I want to write. So this 10 to the power of 3, it is in the denominator. I want to shift it into numerator. So when I'm shifting to numerator, what happens, it will become negative. So I will write this one as 10 to the power of minus 3 kg. Okay. 1 gram is equal to 10 to the power of minus 3 kg. So in this way, we have to solve the numericals. Okay, now I want to give one problem for you. Try to solve that one. That is, convert 1 milligram into gram. This problem try to solve. And in our next class, I'm going to explain about the measurement of time and measurement of density along with numericals. Have a nice day. Thank you for watching.